All right, so in 4.3, we're learning about related rates, and we're going to be doing some simple geometry stuff. The two things we're looking at are Pythagorean relationships and some other simple geometric relationships. I think I'm going to start with number 2 here. There's an airplane that is flying west, going this way as indicated here, 600 miles per hour. This is a rate, okay, on a horizontal path that will take it directly over an observer. Here's the observer. The airplane is approximately 7 miles high, as shown here. How fast is the line of sight distance? The line of sight distance is the distance between the observer and the plane. This distance, I'm going to label this as a variable because obviously it's changing as this plane moves. So like as the plane moves to here, this distance is getting smaller. I'm going to call this C. The reason I'm calling it a C is because it's the hypotenuse of a triangle. I can clearly see a right triangle here. You could have also made a right triangle here, and that will work as well. How fast is the line of sight distance changing when the plane is 10 miles east of the observer? So when this distance is 10, how fast is it changing? So we want to label our variables and our constants. As the plane flies this way, I've already labeled this with a variable because it's changing. As the plane flies this way, this height is not changing. 7 miles is a constant. That's important. This is 10 miles. The plane is right now at 10 miles, but this is a variable. As the plane flies this way, this distance is decreasing. This triangle, is getting smaller. We can see here, like that's what it's going to look like in a second. So I'm going to call this x because it's a horizontal distance. So let's look at what they've given me. The plane is flying west, so the plane is flying this way. So what's happening is x is getting smaller and c is getting smaller. They're asking how fast is the line of sight distance changing. That's a rate, and it's dc dt that I've put in my problem. So dc dt, we want to know how much that's changing by. And they've given me this other rate. This is, since the plane is flying west, x is decreasing. And in fact, dx dt must be negative 600 miles per hour. And that must be true because x is getting smaller at a rate of 600 miles per hour. Okay. So I need a relationship between x and c. And because I have this right triangle here, there's an easy relationship to write. X squared plus, we would normally say y squared, but this isn't a constant, so I can just write x squared plus 7 squared equals c squared. I'm going to rewrite that as x squared plus 49 equals c squared. And to get dc dt and dx dt, I'm going to do the derivative with respect to time. So the derivative of x squared is 2x times, because it's not with respect to x, times dx dt by the chain rule. The derivative of 49 is 0, it's a constant. And the derivative of c squared is 2c times dc dt. And now I can just plug in. When the plane is 10 miles east, so when x is 10, dx dt is negative 600. Now I'm looking for dc dt, so I can leave that blank, but I need to be able to plug in for c, and I don't have c. But they've given me x. X is 10, and so I can just plug in for x to find what c is. So 10 squared plus 49 equals c squared. 10 squared is 100. 100 plus 49 is 149. So c is the square root of 149. I don't need to do plus or minus here because you can't have a negative line of sight distance. It must be a positive. So 2 square root of 149 dc dt. And when we divide, we get negative 6,000 divided by square root of 149 equals dc dt. Do I have a calculator with me? I don't, but I have the answer key, and I assume that this, when you divide it, will come out to be negative 30.188. Wait, is that right? No, this is number 2. This is 491.529. Now, I would say this needs to be a negative number, so negative 491.529 miles per hour, because the line of sight distance is decreasing. Because it's decreasing, that's what's going on. All right, how fast is the line of sight distance changing when the plane is directly over the observer? So the plane is now here, and it's still traveling, right? So let's think. This is still a constant. X is equal to 0 right now. And so we've still got this x squared plus 49 equals c squared. When we do the derivative, we have already done it. 2x dx dt equals 2c dc dt. We can use that answer from the previous part. And so now when we plug in x, we get 0 equals, it doesn't matter what c is, so 2 squared of 149 dc dt. And so dc dt equals 0. So it's saying that the line of sight distance isn't changing at all right then. And that should make sense to you because, think about it, just a second ago, that line of sight was decreasing. That distance was getting smaller and smaller and smaller. This is the shortest distance the line of sight distance will ever get. And then it starts getting bigger again. So the plane starts getting further and further away. So if it changed from getting closer and closer to him to getting further and further away, right then the rate of change must have been 0. That's because the rate of change changed from negative to positive. So, before there was this negative rate of change, afterwards there was a positive rate of change, and so right then the rate of change must be 0. I'll let you do C on your own. It involves a limit. So you need to do a limit. Okay, I think I'll do number 5. A painter is using a ladder to paint the house. There is a 17-foot ladder leaning against the house. So here's the ladder. And it's 17 feet long. Now, is that a constant or a variable? Well, ladders don't change sizes unless it's an extendable ladder. It didn't say anything about that. 2 kids decide to pull the base of the ladder. Here's the base. Away from the house. So they're pulling the base of the ladder away from the base of the house at a rate of 3 feet per second. So what's going to be changing here is I'm going to need to call this a variable. I'm going to call this x. And they're pulling this away at a rate of 3 feet per second. So x is going to be getting bigger. dx dt must be 3. Okay, that's what that is. That's that rate. 3 feet per second is how big this is. Now, as they pull this away, this top of the ladder is going to be sliding down. All right. How fast is the top of the ladder moving down the side of the house when it is 8 feet above the ground? So when this distance is 8, they're looking for how fast the top of the ladder is moving. That's a rate, dy dt. So I need to find dy dt. I know dx dt. I need a relationship between x and y. Y is a variable because this is changing. Now, right now, y is 8, but as they pull the ladder away, that 8 is changing. So I need a relationship between x and y. Again, I have this right triangle, so there's this easy relationship from geometry. X squared plus y squared equals 17 squared. I think it's 289. I don't know. I'm going to write it for now. And so when we take the derivative with respect to time, notice that in our last problem, the y was a constant. Y is not a constant here. X is not a constant, but 17 is a constant. So when I take the derivative, I get 2x dx dt plus 2y dy dt equals the derivative of the ladder's length is 0. That's basically saying the ladder isn't changing in length. And that should make sense. So y is 8. I'm going to plug that in. Dy dt is what I'm looking for. I know dx dt is 3. And I don't know what x is. But again, if I know that y is 8, I can plug in 8 into my equation that relates x and y. X squared plus 64, that's 8 squared, equals 289. I can subtract and get x equals 15. Again, I don't have to do plus or minus 15 because this distance must be a positive distance. So x must be 15. So 30 times 3 is 90 equals plus 16 dy dt equals 0. Subtract the 90. We're just trying to get dy dt by itself. It's a linear equation now. Subtract the 90 and divide by 16, and we get dy dt equals negative 5.625 feet per second. Now, how fast is the ladder moving? I don't think we need positive or negative here. The speed is the absolute value of velocity, and it's just positive 5.625. That's how fast it is moving. It didn't ask for a direction. So I disagree with the answer key here. All right, when the top of the ladder is 8 feet above the ground, so same situation, how fast is the area of the triangle changing? So they're looking now for dA dt. So I need to set up a relationship between area and the rates I have. So the area of a triangle, you are supposed to know, the area is 1/2 the base times the height. And in this case, I'm going to rewrite this as area equals 1/2 the base of the triangle is x, and the height of the triangle is y. And so to find dA dt, I'm going to do the derivative, and this is a product rule. The derivative of the first one is dx dt. Leave the second alone, plus we leave the first one alone, times the derivative of the second. And we have that constant multiple in front each time. And so we've got this. Now, we already know what dx dt is. That's 3. We already know what y is. Y is 8. We already know what x is when y is 8. X was 15 from before. And we already found dy dt. dy dt was negative 5.625. Now here it matters that it's a negative. And you just add those numbers up and you get dA dt. And that will be in feet squared per second. And the reason is because area is measured in feet squared. All right. I think I'll do one more. I think we have time for one more. The radius of a circle is decreasing at a constant rate of 0.1 centimeters per second. So that's dr dt. The radius is decreasing at, and because it's decreasing, it's negative 0.1 centimeters per second. Okay. In terms of the circumference, means there's going to be a circumference left in our answer. What is the rate of change of the area? The rate of change of the area is dA dt. That's what they're looking for in square centimeters per second. So we're looking for dA dt. So area of a circle is pi r squared, which is great because we have dr dt. So we're looking for dA dt, we've got dr dt, we're set up. Take the derivative with respect to time on both sides. dA dt equals, pi is a constant. The derivative of r squared is 2r times dr dt. And we can plug in. R, we don't know r. And we have no way of finding r, but dr dt is 0.1. So dA dt equals 0.1 times 2 is 0.2, so 0.2 pi r. Now, it said we might look at our answer choices and say, hey, none of these say this, and let's remember that it said in terms of the circumference. This is in terms of r, the radius, but we want in terms of the circumference, or c. So we need to find a way to change r to c. Well, we know an equation that relates r and c. The circumference of a circle is equal to 2 pi r. You need to know these formulas from middle school. And since we know this, we can substitute r with c's by solving for r. R equals c divided by 2 pi. We just divide both sides by 2 pi. And so we can substitute what r is equal to in here and get it in terms of c. So dA dt equals 0.2 pi times c divided by 2 pi. Multiplying by pi and dividing by pi cancel out. 0.2 divided by 2 is 0.1, and so we get d ADT equals 0.2